Good morning, and let's get started. I am Tim Berglund, and I do understand that I don't pronounce that correctly. I have received some coaching. I'm told it should be something more like Berglund. Is that decent? Okay, there's not a complete consensus. It sort of depends who I ask. Sometimes the G comes out a little harder, but I say the G good and hard. Berglund. I live in the United States, in the city of Denver, where it is currently colder than Stockholm. That I was not expecting. Let me bring up my slide deck. Here you go. I am the director of training at DataStax. At DataStax, we make a commercial version of Apache Cassandra. Cassandra is a big data database. I'll be giving a talk on it later in the day. And so you might be wondering, why am I talking about Git? Well, I used to talk about Git a lot. So this is material that I've taught lots and lots, and we actually use it on my team. My team builds a website. Of course, we use Git for that, and we also build curriculum. Traditionally, enterprise training curriculum is built in things like PowerPoint and Keynote, where you don't want to put those files in Git for various good reasons. But we actually do all of our curriculum in AsciiDoc. There was a talk yesterday on AsciiDoc here. So my curriculum team uses Git and GitHub all the time. So these skills are really important, even to my team who's building slides and exercises for delivery in the classroom. This is important stuff. And I assume you're here because Git matters to you as well. Now, here's an interesting question, just to get you warmed up. It's early. Who here would consider yourself new at Git and sort of like Git is a little scary to you? Okay, all of you with your hands up should leave. Don't really leave. The purpose of this talk is to do two things. There will be some practical skills that you can take away. Some things like the reset command, and hopefully we'll be able to play with rebase a little bit. These are useful things to know about that feel like advanced commands, but sometimes are really, really handy to have, and they can save you when you make mistakes. So those are the practical takeaways. Now what I'm going to open with is in my first bullet here, I'm calling the hipster commit. And this is a series of commands that if you ever actually use them, not in front of an audience, not as a part of a party trick, maybe you should get fired. They're not very practical, but there is a deeply practical reason for the exercise. And that is this: Git scares people, and it doesn't need to. People feel like, oh no, if I do the wrong thing, stuff will get lost, and it's like this magical beast, and if I anger it, it'll do mean things to me. I mean, I still meet people, there's people on my team even, who are a little afraid of it, and you don't need to be. So we're going to do this funky commit thing. I'm going to make a repository, and I'm going to make a commit without using the init command, the add command, or the commit command. That's not because you ever want to do that, but in the process of going through those steps, I'm going to show you a little bit of how Git is composed under the covers. And the purpose there is to try to take a little bit of the magic away. If you take the magic away and realize that this is actually a machine, and there are mysteries in your life, that's good. Git's not one of them. This is a machine and you can reason about it. So that's kind of where we're going with this. It's intended to make you a little more comfortable thinking about what's going on inside a repository. So let's just do that. All right, here we are. Now, where am I? You can all see me, right? Font size good in the back? Really? Hi, up there. Okay, good. We got that font size. Excellent. Now, again, the uncool thing to do here would be that. That's way too mainstream. We're not going to do that. So I'm going to make a repository, and sort of by tradition, I like to use poems to demonstrate Git. So I'll just make that repository. Good enough, right? And let's do a git status. And git status is absolutely not impressed with my work so far. Who can blame it? Now, I'm going to need to go over here as well and if you don't mind, I'm going to do a little bit of this. It's just a one-line bash while loop that's going to continuously clear the screen and print out the contents of the .git directory and then do it again. And you may say, what .git directory, Tim? You didn't make one. And you would be right. Tree is not happy with that. So maybe you've looked before and seen in a Git repository, there is this directory called .git with stuff in it. And when you just do git init, that's really what's happening, is the init command is making that .git directory and putting a bunch of boilerplate stuff in it, which means this is a Git repository. That is, to some degree, what it means to be a Git repository is to have this thing. Now, I've got that. It's not complaining anymore. That's good, but it's not enough merely to have that directory. There's a few things that go inside there. Let's take a look at what those are. So, I want a directory called objects. Now, objects is where Git stores everything. One extremely unhelpful definition of Git is that it is a content addressable file system. Don't ever try to explain that to a newcomer, because that will just make them sad. But it is, and when you add a file to Git, what happens is you're hashing that file. So you come up with the SHA-1. Turns out it's SHA-1 is the hash function that it uses. You take the SHA-1 of that file and then compress that file and store it under the objects directory in a subdirectory named after the hash. So I take content and I store it and I address it by its content. That means if I ever try to store exactly the same file in two different subdirectories, say, in a project, I can't actually store two copies of it. I'm storing that content once. So Git stores content. Git tracks content. It always stores copies of things. And this is often a revelation to people when they realize, because if you just kind of started from zero and you said, I'm going to build a version control system, everybody knows that you'd only store changes, right? You wouldn't store whole, fresh copies of files. If you're going to make a little change to something, you just store the delta. Git, to some approximation, doesn't do that. It just stores whole copies of content, and those copies of content go in the objects directory. Of course, it also needs a way of referring to them, and that stuff happens in the refs directory. Maybe you've heard or read in a Scary Man page about a thing called ref spec. And a ref spec is a way of addressing a commit in Git. It's a label for a commit. And those go under here, and we have a very specialized form of refs called heads. And once we have that, let's see, is status impressed yet? Status is not yet impressed. It's almost there. Let's see, we need one more thing. We need to echo refs, refs, heads, master, to .git head. Let's see if I've got that right. Look at that. We have created a Git repository. Who needs Git init? It puts all this extra stuff in there. You just do that. It's so easy. And actually, Git init doesn't put too much extra stuff in. And the stuff it puts in there is configurable. There's a default template directory in the Git installation. You can override that with a global property or a command line parameter. If you create a lot of repositories and you have a certain template for that, that's kind of weird. Nobody ever really overrides it. But like hooks, we won't talk about hooks today. But once you feel free to poke around in .git, poke around in the .git/hooks directory sometimes. Those are scripts that you get for free in the default Git init. But we don't need any of that. We are here, and we have a Git repository. And as usual, Git doesn't care about your feelings. If it did, when you type log on a new repository, it wouldn't start the response with the word fatal. That's a little jarring. This is a perfectly normal error here. This just means we don't have any commits. It could say something like, hey, your repository is empty. But, that's not what we get. All right, let's do our next step. I'll just clear the screen. I don't want to use add. I don't want to use commit. I want to use echo. And I have to pick a poem. And please believe me when I say I'm not pandering, but I'm going to use the first line from Beowulf. And this is the Seamus Heaney translation of Beowulf. My father's people were Swedish. My mother's people were Irish. Seamus Heaney is Irish, so this works out pretty well for me. So, the spear Danes in days gone by, and the kings who ruled, kings, we'll do diff later. Kings who ruled them had courage and greatness. We have heard of these princes' noble campaigns. And that's our text, echo, good enough. You guys know the story of Beowulf, right? No? Did you read that like in high school? Surely. No, okay. Well, it's about a Danish guy, a Danish king, who's in trouble and can't solve his own problems, and a Swede comes down and fixes them. Not making that up. I didn't write it, okay? And it actually, it's a good poem, I think, for software teams. It's kind of about the hero culture. That's a different talk. Maybe we can talk about it at lunch. But it's directly applicable to our work. Anyway, I'm going to take that echo, and I'm going to pipe that to a command called hash object. And I'm going to tell hash object a couple of command line parameters. What hash object is going to do is going to take its input from standard in. It's going to hash it through the SHA-1 hash function, and -w write it into the objects directory, and then tell me the hash. Now you see what just happened. We're getting some wrapping over there in the tree. These are big, long directory names. It's not beautiful, but it just created a directory under objects and then a file in that directory. Now the directory is 1.5. That's the first two characters of the hash, and the file name is the remaining characters of the hash. So when we say content addressable file system, you just saw it happen right there. We have a blob of content, and it got written in there. This is a loose object, is what this is called. I'm going to copy that, because I'm going to need that in a minute. In fact, I could even use it right now. I'm going to use the show command to show you what that looks like, or I suppose it would be a little more precise for me to use this extremely well-known command, catfile. Obviously, you all know catfile. Oops, I need to tell catfile what I want. I can ask catfile, how long is that content? It's 141 bytes. What kind of content is that? What type of content is that? It's a blob. Would you print out what's in that content? Well, there you go. And that, guys, those three things, if you were to look inside that, it's a zlib deflated file. If you were to deflate it, you'd see the word blob, the number, was it 147, and then these characters. That's all that's in there. There's no metadata, there's no file name, status, doesn't care at all. I've just got a blob. So this is the very beginning of what add does. When you run add, it does this. It will create an object. So let's take it a step further and update the index. Well, what in the world is the index, and why are we doing this? Do I still have my hash on the clipboard? I do. Good. This is another key Git concept, and to newcomers to Git, I had one, by the way, a year ago. A guy I hired, he was a university instructor and super smart guy, a lot of fun on stage. He does great screencasts, lots of personality, very loud and American, and we love it. I don't know why I love that so much. Reminds me of somebody. Anyway, he was a Subversion user at his school. They just had never used Git. He was new to Git. And so I got to experience another new Git user, and this whole idea of the staging area bums them out. when you're new to Git. You have to add and then you commit. Subversion, you only ever add once, and then it just knows that it should keep track of that thing. But in Git, you always do that. Every time you need to commit, you need to add first. And so there's this kind of three-stage world where you've got your files, or what we call in Git your working tree. I'll show you in a minute. I have no working tree right now. I don't have a file called Beowulf. But normally you've got your files, your code that you work on. And then there's your history over here, your commits and stuff. You kind of get that. And in between there's the staging area. And you go for your files and you add, things go into the staging area. And then when you're ready, you can add multiple times, you can reset things out of there. You kind of get this staging area ready, and then that turns into the next commit. So there's this place where you work on what your commit's going to look like. And that often bums out people when they're brand new to Git. When you get used to it, you think, no, actually this is good. I can make a commit look like what I want. I have some control over how this is crafted. But that right here, that is called historically the index. We call it in polite company the staging area now, but internally it's called the index. So I'm going to run this update index command, and here is where we start talking about a file name. I'm going to tell it I'd like to add something, that hash, which is my blob, and I want to give it that file name. No new blob has been created, but something happened over in the file system. Did you see it? We now have a file called index. So that is, something has been staged, and look, status sees it. This is so great, you guys. I mean, if I just added and committed, this would have been done 10 minutes ago. But hey, we're learning a lot. So let's think through this, because this is another thing that's important. New file, beowulf.txt. It has been staged. It's in the index. And only now does it have a file name. Like I said, when I created the blob, there was not a file name. There is no file name metadata in blobs. But there's one in the staging area now. And it also interestingly says, oh, by the way, you have this tracked file called beowulf.txt, which doesn't seem to exist. And so apparently it's been deleted. So Git believes that has been deleted. And that, just so you know, in this ridiculous commit exercise that we're working through, will be the last problem we solve. So it's going to be complaining about that until we're done with this. Now, I have added this to the index. I've got an index. That is my staging area. Now I'm going to do a deceptively simple command called write tree. Now, this is the second kind of object in our Git content universe. The first was a blob that we created with hash object. Now we're going to create a tree. Now that gives me, you saw that created another object, and that returns the hash of that object. 8F, 5F, F31, etc. Let's go ahead and...
What was the cache info that you had?
Oh, yeah, I didn't explain that. Thank you. Cache info is the mode, the file mode. Yeah, so the 100 is some internal stuff whose meaning actually escapes me. I've never looked it up. So I'm just going to be transparent about that. I forget what that 100 is. 644 is the mode. And that is a thing that Git cares about. By the way, the asking a question when you had one, that was a power move there. So anybody else wants to do that? Do it, please. The worst I will do is say I don't know. All right, I'm going to clear the screen here. You don't have to say it out loud, but I want you to form an expectation in your mind. Guess what's going to happen. No. Who said that? Oh, yeah, it is. This is just a big, giant pair programming exercise, except there's like 200 of you and one of me. Okay, so you're right, there was an error. Anyway, here you go. This is a directory listing. And that's what a tree is. A tree is a directory listing. It's an object that's stored in Git. Think of it like a text file. It's like you wrote that line of text. This is a fairly lame directory. It only has one entry in it. But a tree obviously can be very long. It's like you wrote a line of text, and that line describes the mode, the type, the hash, and the file name. Some of these, of course, can be other trees. Directories can contain directories. So if I have a subdirectory, then it'll say the mode tree, a hash, and then the name of the directory. We're not going to do that. We're just doing one file because this is hard enough. But there you go. That is what a tree is, and that's another kind of content. So if you change a file name, that's going to create a new tree. If you change the content of a file in a directory, that's going to create a new tree because the hash will change here. And the hash of the tree is just the hash of this text file here. So if I touch anything in a directory, content or name, I will get a new tree object. If I don't, I can reuse a tree object. For as long as that project, I can commit as much as I want, but if source main resources doesn't change that often, that tree will be fixed from commit to commit. We'll just keep reusing that. All right. Where am I? I want to check status. Status didn't even care that I did that. I'm a little hurt. That's because we need to create another kind of object, and that's a commit. Now commits, you see hashes in Git all the time, and we're kind of used to that, and those are typically commit hashes that we're seeing. Blobs and trees are fortunately invisible to us most of the time. This finally, in committing the tree, is going to create a commit, and we'll just say hipster commit, and keep your eye on the ball. That has created 47 db52, etc., etc. Status still not happy. But we have a commit pointing to a tree, pointing to a blob. That's really what we have here. Let me show you just a picture. No slides, but I couldn't resist. I wanted to show you a picture. Normally, commit, that's what we see, right? We see a history of commits. And sometimes they branch and they do interesting things, and it looks like Guitar Hero or generative art or something. What we're looking at is really this stuff here. We have a commit that's pointing to a tree. In our case, I'll just delete that. And that tree is pointing to a blob. This is, here. That's our repo. That's what we've got. Inside the commit, and so you're asking, what is a commit? Let me show you. Actually, I can cat file on that guy. I'm going to type, wise guys, git cat file. That is a commit. The commit object is also just a text file. You could print that out and you could zlib deflate it and put on the length and the content type. That'd be a little bit of a pain. But you could handcraft this. Tree, author, committer, parent. This is a root commit, so it has no parent. But subsequent commits will have a parent or parents if they're merge commits. And then the message, the commit message. This text file is hashed. That is the commit hash. So you can see, looking at this guy, if I change one bit in a blob, I get a new hash. That means I have a new hash in my tree. That means my tree hash is going to change. That tree hash is represented in the commit. I hash that commit file. I get a new commit hash. That's why you're guaranteed a new commit ID every time you change anything. And the only way to get the same commit ID is to have absolutely the same everything all the way down. Or a SHA-1 hash collision, which is, I've never really done the numbers, but it's probably less likely than us getting killed by a meteorite today. So usually not a big concern there. Unintentional SHA-1 hash collisions. Intentional SHA-1 hash collisions, I'm told, are easier than they used to be, but this is not cryptographic hashing, so we're cool there. All right, we need one more thing, and that has to do with this heads directory over here. Heads are branch heads. So the local branches you have in a Git repository will be reflected as text files under .git heads refs. And I'm going to make one of those with a command. I could just make the file if I wanted to, but I'm going to be a slightly better boy than that. I'm going to use the update refs commands. Refs heads master, that commit. Refs heads master is the formal name of master. That's the full name of that thing. And all that command is going to do Okay, so it does a few slightly more interesting things. But fundamentally here, guys, it just created that master file. And that's what a branch is. That's why branching is so quick in Git, because it just created that file and wrote 41 bytes to it. 40 bytes of SHA-1 and a new line. That was a good idea when Linus came up with that. It also, you may notice, created this logs directory, which we will revisit by the time we're done here. But I'm happy to report, almost there. The green is gone. So let's see here. Hey, we have a commit. Can I show that commit? Yes, I can. So the spear days and days gone by, and the kings who ruled them had courage and greatness. That's wonderful. Now, what's missing? The actual file. So that's why status is saying, look, you've got beowulf.txt. It's apparently been deleted. So here's another cool thing that is good to know about. Checkout is normally the command for switching between branches, but if you'd like to be a little more surgical and just go grab a file from a commit, let me be a little more explicit here because this shortcut is confusing. I want to go to head. I don't really want to check it out, but the dash means please visit that commit, and for the path I give you, go get that and dump it into my working tree. So that's like Git normally does not stop to give you any affirmation when it does the right thing. But status is clean, and I have an actual file. Ladies and gentlemen, the hipster commit. So. Please don't ever do that. I mean, except like as a party trick, it's cool. But again, what is cool and what is very important to you as a Git user is seeing things, seeing the internals enough to know, look, it's okay. It's just a machine. I see what it's made out of. I can do this. I mean, that's the purpose of the exercise is to give you a little confidence in reasoning about Git. So with that, let's move on to some other things that cover actual use cases that you might get into and actual commands that you should run when things happen. And we're going to have to type some more Beowulf lines and maybe come up with some more poems. We've got about 22 minutes left, which is plenty of time. And I said, let's see, what did I tell you I would do? I told you I'd do reflog and reset and interactive rebase. I think those were the key things in the description, and I want to make sure everybody gets what they came for. So reflog. Now, reflog is so important and not super informative yet. Trust me, it's a big deal. We're going to have to do some more to make this a little more interesting. All right. So I'm going to go back in here and let me add some more. There was Shield Sheafson, scourge of many tribes. He was the Danish guy who couldn't take care of his own stuff. All right, and commit. Oh, you know what? The thing over on the right, it's not fun anymore. Right? That has officially stopped being fun. So let me do this. I'm going to shrink that up a tiny, and I have a command here called git log live. Now, that's just gonna update. Oh, right. You're supposed to call me out on my mistakes, guys. Boom, there. But now you got to see it happen. Git log live is just a script like that one before. It's just a while loop that's calling a flavor of the log command, sleeping, and then clearing. So it's every second it's going to update my history. So we'll see things unfold over there, and it's way more fun than the object view, which, you know, after the first commit is simply not fun anymore. All right, I'm going to need a few commits here. Shield Sheafson, he was a wrecker of mead benches. rampaging among the foes. And what do we do? We're doing reflog and reset. Can I, if you don't mind, here, I'm gonna keep a copy of that, and then I'm gonna delete that. He drank a lot and beat people up. Oh, good. That wasn't even intentional. So, that makes me so mad. No, what are we gonna do about that? Okay. If only Git. Oh man. If only it gave me a way to do that. Let me just. We'll just call this a bug. That's a bad Git commit comment. I'm just gonna soldier on. You're right, I misspelled it, but I don't think there's any way to fix that, possibly. So it's too bad for me. Git add. I'm just making some history, you know? And not typing properly. All right. And then I'm like, wait a second. That's just wrong. So what do I do here? Because I could just fix it, but I haven't pushed yet. That's key. And you don't necessarily want to publish a record of your failures. Sometimes it happens. And if I had pushed this commit to GitHub and other people saw it, then I'd be kind of stuck. To fix it at that point is a different topic and much harder. So once you share a commit and you want that commit to go away from history, you, instead of Git being an asynchronous development tool or collaboration tool, it becomes a synchronous collaboration tool. And Git does not give you synchronous collaboration features. So where do those features come from? From you. You go around to the other people who use the repository and you say, hey, stop doing everything, commit everything and push it, and then delete your working copy, and I'll tell you when you can clone again. That's what I mean by you provide the synchronous features. And basically, nobody likes you when you do that. So it has to be worth it. This, for example, the spelling error, not worth it. If I had pushed this, no way. All right. But sometimes there are things that matter, like, I accidentally committed a bunch of production passwords or something, and then you have to either roll credentials or do something destructive. I will not walk through that workflow. I will, however, look at what we can do here, and that is, I wasn't even sure we were going to do this, but let's do it now. An interactive rebase. Oh boy. Now, rebase is a command that scares a lot of people, and my opinion of rebase has changed over the years. Rebase interactive, always a good thing. Good tool, gotta have it in your tool chest. Rebase by itself, I'm sure there are opinions on this in the room. I'm kind of now of the don't do it party. It's usually thought of as a thing to do instead of merging. That's not quite precise. If you don't know rebase, don't worry. We're not going to go into it. If you do, stop using it. Except when it comes to interactive rebase, this is a really good thing. And what it does is it goes back in history and lets us reconsider those commits. We can rebuild things. And I gave it a particular commit. I'm saying, please go back up until 47db52 and then not quite to that commit. So the 3 commits between me and the one I name are the things I'm going to get to redo. Oh, I forgot. I have Adam set as my default editor, so we have this guy popping up here. Let's talk about interactive rebase just a little bit. Now, I get this file, opens up. I have in reverse order a list of the commits that I've got in that range. I identified those 3 commits. And I get this little recipe, and it tells me pick. What that means is, but the default interactive rebase recipe that I'm giving here, when I save this file, rebase-i is going to execute this file. It's going to take each of those commits and rewrite them in the same order exactly the way I wrote them. Okay? which is not that exciting, right? But I get down here different commands that I can use. There are things I can do. Very typically, what people use interactive rebase for is to squash commits together. Because when you're working, hopefully you're committing fairly frequently, just because. But that might not be a very effective way to share your history with your team. So some people, before they push, they'll interactively rebase and squish stuff down together a little bit. Now, this is advanced game, and you don't need to be like this. But some people, when they're very comfortable with Git, they say, you know, I want my commits to tell a story. I don't want them to be just random, I happen to hit Command S at the moment, snapshots. I want them to be coherent stories. And you can use rebase-i for that. You could also use it to fix problems. So this guy, Shield Chiefson, I don't want to pick that. I want to edit that. So I'm going to go back in time. I'm about to save this file, exit Atom. I have gone back in time to the commit that I identified. All right? And the history is going to be weird. So the thing on the right, if you have a habit of doing that, don't do that during an interactive rebase. Just don't worry about it. All right, now I'll go over here, and this is how things were back then. Remember those days? It was about 7 minutes ago. I'll fix that spelling error, and I will get add, and I get these nice instructions here. It says, hey, you're in an interactive rebase. You have this edit you're working on right now, and then you're going to pick, and you're going to pick. By the way, this has been improved in recent versions of Git. Before it was like, whatever, something's going on here. But now it's giving you a good summary, and it tells you use git rebase continue once you're satisfied, and life moves on, and I, of course, have to provide a new commit message. I'm perfectly satisfied with that one, and there we go. Why could you not apply? Hey, sometimes when you do this demo, things get interesting. This is great. The reason this happened is because I changed a line that was at the end of the file, and then the next commit put another line at the end of the file. And when you're adding on things to the end of the file, those look like merge conflicts to Git. So this was a merge conflict. This was not a part of the plan. But it's not that hard to fix. All I do is delete that. And you know what? Turns out, oh wait, that was an error too. I didn't even want that. And of course, it's going to do it again, right? Scourge of many tribes, a record of meat bunches rampaging among the foes. No more spelling errors, good. And finally, yes. Now, here's another question, and it's too big of a room to actually call on people. But how many commits do we have before? Somebody can shout this number out. Am I wrong? We had 4, didn't we? We had 4. We have 3 now. What happened?
2 of them were the same.
2 of them were the same. Exactly. This is another recent improvement in rebase. I was expecting to have to introduce yet another rebase command that I was going to be angry about, but rebase has gotten a little smarter about this. And what I did was I introduced a line at the end of the file that was not necessary at all. And I took that away. I said, wait, this is a bug. I don't even want that. And rebase said, actually, this blob is the same as the blob was before. The tree is the same as it was before. The commit is the same as it was before. So you're trying to make the same commit twice in a row. You can't do that. It's like you're not even making a commit at all. So it just took it away. You can't make the same changes twice. It doesn't mean anything in Git. So there you go. That's a slightly more interesting case than I was actually even hoping for. So you guys lucked out. And so did I, because that worked. All right. there we are. Now, we need to cover reset and reflog, and I've got about 10 minutes left, which is enough time, if we're careful, because these are handy things. Now, I showed you reflog before, and it was pretty frustrating. It's way cooler now. Reflog is a record of the changes you've made to refs locally. Refs, if you'll remember, are pointers to commits, and the refs that you typically change are branches. Also, head counts as a ref. Head, I created head. I put some file in head, or some content in head early, and it wasn't, I didn't explain it, I just put some stuff in there, like, hey, don't worry about this, just need this. Head is the commit that you're on right now. And this is a symbolic ref pointing to master. This is Git's way of saying you're on master. Now that can be a hash. Instead of refs heads master, that can be the hash of some commit. And that's what Git calls detached head state. Maybe you've been in detached head state before in terms of Git. Not in terms of your physical body. I don't think you'd be here. I mean, people can do that, but just unidirectional. Git, you can go back and forth. But yeah, this means that we are on the master branch. So what I'm saying, the reason for this explanation is, if I switch to another branch, head changes. That is a reflogged thing also. All we have in reflog so far are my 4 commits. This first one is lame because I did it the hipster way. Commit puts interesting content into the reflog. My way of committing is a little weak, but the actual commit command now has these useful log entries. So reflog is a record of commits, rebases, resets, checkouts. Basically, those are the things that are going to show up in there. Changes you've made to refs. Why do you care? Well, what if I wanted to undo my rebase, for example? I said, no, I like it the way it was. I want to go back to that and fail forward instead of rewriting history. Well, the hash has changed. I lost a commit, and you probably didn't write them down. If you took a picture, go back and look at it. But the hash has changed after the rebase, and now you know why they have to. If I wanted to undo that, I actually could by using reset hard. Okay, reset hard is one of the sharpest knives in the Git toolbox. So be very careful with this. I started out by saying people are afraid of the mystery of Git, and they say, oh no, I'm afraid if I do the wrong thing, I'll lose work. Or people will tell stories about, oh, there's this time I did the wrong thing and I lost work. And fair enough, if you don't know where to look for it, it's lost. I mean, it being somewhere and you not knowing where that is doesn't do you much good. But now that you know reflog, my friends, you never have to lose anything, okay? If I want to go back to that thing before my rebase, I look at the reflog, I go back in history, and I can see here is where I started my interactive rebase. This clearly is the commit that happened before then. So I'm going to reset hard to that, and hey, look, I have 4 commits back, and they're different hashes, and I've got my spelling error back, and I've got my bug back. So you may be thinking, that is the worst demo of reset hard ever. You just restored 2 bugs. Why would you do that? Hey, look, there could be a reason for it. I don't know. I only work here. But I have now a new entry in the reflog.
So that also means that if you had actually committed the password to the thing, even if you kind of rebased, that the password would still be in Git?
Yes, the password is still there. So that was my good reason for rebasing that I gave. So let's just walk back through that. Imagine if I'd committed a password and I pushed it. That's trouble, and that is where I have to go synchronous, which is a collaborative activity where I say, stop, I made a mistake, stop, and you fix it that way. You are correct, the blob is still in the repo, and that commit is still lurking back there. There is a command called gc that I can use to garbage collect that and force that stuff to get wiped. I won't do that now because we only have a few minutes left, but very good point. I wasn't even thinking that, but yes, you'd have to gc that if you need to be completely careful about it. I don't even want that. I'm just going to go back to, let's see, D4DE. D4DE, yeah, that's good enough. That was when rebase was done. I do want to go back to that version of things. So I have complete control over where I live. Now, why is reset -- hard such a sharp knife? You see here that you never lose anything. It's always there. Go to the reflog. If you've done complex things, if you're switching between branches and rebasing and doing all this stuff, it can be hard, folks. Question?
Commit number 2 and 3 are the same hashes.
Those are reflog entries that are the same hashes. So reflog, or rather rebase, says, here's the last thing I wrote, the last commit I wrote, and now I finished. And those are two separate reflog entries pointing to the same commit. So you can definitely have lots of reflog entries that point to the same commit. That's fine. Yes?
What about the hard option there? What is it? Non-hard?
Nope. Yes, there is. There's a soft and there's a mixed. Soft will move the head back to where you specify and leave all your files in place. And so does mixed, actually, in the working tree. Hard is the sharp knife, okay? You never lose anything in Git, except when you reset hard and you have uncommitted changes. That is when you irrevocably destroy content. What that will do, what reset hard does, is it moves to the commit you specify, moves the head there, and if you're on a branch, moves the branch there, and then rewrites the working tree to look like that branch. We saw that happen with Beowulf. So if you've got uncommitted changes to tracked files, they're gone, and you can never get them back through Git. If you happen to have a backup somewhere else, that's fine. But that's where I say sharp knife. So that's dangerous, but this is such a useful tool. You make a few commits, and you oh no, I didn't mean to do that. Let me just forget everything. It's been a bad day. Everything I've done this morning, I just want to go back to where it was at 8:30. You can reset hard and come back to that, and that's very useful. If you've already pushed, once again, and you reset back to before what you pushed, then you're in trouble, so don't do that. But super handy tool. In combination with reflog, you have complete control over local history to go back to anything you need to. And that, trust me, very practical. This gets you up into advanced Git user territory. The committing with hash object and everything, they're fun. You do it in front of somebody and impress your friends. That's good to tell you the internals, which you know a little bit of now. But commands like reflog and reset have got to be in your toolbox if you want to go to the next level. So with that, we're out of time. I want to thank all of you for being here early in the morning and hope you have a great day.